Nvidia accelerated computing starts with DGX, the world's AI supercomputer, the engine behind the large language model breakthrough.
We want to ensure that the outcome reflects the principles at the core of our products.
What if Apple, the company behind your iPhone, is about to crush Nvidia, the king of AI and gaming tech? With the revolutionary M3 family, Apple is challenging Nvidia in AI, gaming, and high-performance computing, areas Nvidia has ruled for years. Trade restrictions, billion-dollar markets, secret AI models, and a war for technological dominance. This rivalry is bigger than anyone imagined. Will Apple's vision and innovation shatter Nvidia's empire? Or will Nvidia fight back and redefine its future? Stay tuned, because this is a battle that could reshape the tech world forever. Is Nvidia's reign coming to an end? How did one company rise from making graphics cards for video games to becoming the backbone of the world's most advanced artificial intelligence systems? And more importantly, why does Apple, a titan in its own right, now see this company as its biggest threat? The story of Nvidia's dominance starts in the mid-1990s, when the tech world was grappling with the challenge of making computers capable of producing realistic graphics. Nvidia entered the scene with a vision to create technology that could handle the massive calculations required for rendering three-dimensional environments, something that was largely confined to high-end workstations at the time. The pivotal moment came in 1999, when Nvidia introduced the GeForce 256, the world's first GPU, or graphics processing unit. Unlike traditional computer processors, which handle tasks one at a time, the GPU was designed to work in parallel, solving thousands of tasks simultaneously. This breakthrough not only transformed gaming, but laid the groundwork for Nvidia's rise in artificial intelligence. What makes Nvidia's GPUs so critical today? Fast forward to now, and Nvidia's reach extends far beyond gaming. Its GPUs power everything from self-driving cars and medical research to the vast neural networks behind applications like ChatGPT. What makes Nvidia special isn't just its hardware, but its ecosystem. A key piece of this puzzle is CUDA, short for Compute Unified Device Architecture, a software platform Nvidia introduced in 2006. CUDA made it possible for researchers and developers to harness GPUs for tasks far beyond graphics, like analyzing vast datasets or training AI models. CUDA isn't just a tool, it's a strategy that has locked in loyalty from the scientific and AI communities. If you're building cutting-edge AI, chances are you're using Nvidia hardware. But now, is Apple about to steal Nvidia's crown as the king of AI hardware? To answer this question, we first need to understand how Nvidia's influence in artificial intelligence is unmatched. Their GPUs have become the go-to choice for training deep learning models, the foundational technology behind applications like voice assistants, image recognition, and even drug discovery. Deep learning requires a massive amount of computational power because it processes and learns from enormous datasets. GPUs, with their ability to handle parallel tasks, are perfectly suited for this. It's not just tech startups that rely on Nvidia. Industry giants like Microsoft, Google, and Amazon use Nvidia chips to power their AI systems. Nvidia's GPUs essentially form the infrastructure of modern AI, much like highways form the backbone of transportation systems. The numbers are staggering. By 2024, Nvidia's market valuation surpassed $3.4 trillion, making it one of the most valuable companies in the world. It's rare for a chip maker to achieve this kind of dominance, but Nvidia is no ordinary company. Its GPUs are at the heart of industries that are reshaping the future. Take cloud computing as an example. Companies like Amazon Web Services and Google Cloud depend on Nvidia's GPUs to provide the computing power their clients need to train AI models or run high-performance applications. In many ways, Nvidia isn't just supplying chips, it's supplying the tools to build the future. But if Apple's M-series chips match Nvidia in AI benchmarks, could the world's reliance on Nvidia crumble overnight? And what about the gamers who have fueled Nvidia's growth for decades? The company's RTX series GPUs are considered the gold standard for gaming graphics, introducing features like ray tracing, which simulates how light interacts with objects to create incredibly realistic visuals. Gamers wait for Nvidia's product launches with the kind of anticipation usually reserved for Apple's iPhones, underscoring the brand's strong consumer loyalty. This dominance didn't come easily. Nvidia has consistently stayed ahead of its competitors by pouring resources into research and development. Their strategy is clear: innovate faster than anyone else. When AMD, a longtime rival, began catching up in gaming GPUs with more affordable options, Nvidia doubled down on AI-specific chips like the H100, specifically designed for high-intensity tasks like training large language models. And it's working. Nvidia has firmly positioned itself as a leader, not just in one market, but in multiple sectors that define the future of technology. Here's where things get really interesting. Nvidia's influence has become so pervasive that it's starting to draw attention not just from competitors, but also from governments. With AI and semiconductor technology now considered critical infrastructure, Nvidia's chips are increasingly subject to export controls and geopolitical scrutiny. The company recently faced restrictions from the US government on selling its most advanced AI chips to China, signaling just how vital Nvidia's technology has become in global politics. Yet for all its success, Nvidia's reign is now under attack. Apple, with its launch of the M3 chip family, has set its sights on Nvidia's turf. And Apple is no ordinary competitor. It's a juggernaut with the resources, vision, and ecosystem to strike at Nvidia's greatest strength: innovation. Can Nvidia stay on top, or will Apple redefine AI, gaming, and computing forever? Is a new tech giant about to take the throne? Apple's M3 chips take center stage. Apple has just released a chip so powerful, it threatens to dismantle Nvidia's dominance in artificial intelligence and gaming. Apple's M3 Max chip isn't just a minor upgrade. It's a seismic shift in computing, one that has Nvidia's leadership watching closely. With benchmark performances rivaling Nvidia's RTX 4080 and outpacing expectations in artificial intelligence tasks, Apple is no longer simply competing. It's signaling to the world and to Nvidia that the battle for supremacy in high-performance computing is far from over. Apple's announcement of the M3 lineup, comprising the M3, M3 Pro, and M3 Max, has taken the tech industry by storm. Built on an advanced 3-nanometer process, these chips represent the cutting edge of semiconductor manufacturing. For context, the size of these transistors, measured in nanometers, determines how many can fit onto a single chip. The smaller the transistors, the more of them you can pack into the same area, resulting in greater power and efficiency. At 3 nanometers, Apple is ahead of most competitors, with Nvidia still relying on 5-nanometer processes for some of its GPUs. The M3 Max, in particular, has grabbed headlines. This chip boasts a GPU with 40 cores, enabling it to deliver staggering performance in graphics-intensive tasks like gaming, video rendering, and artificial intelligence computations. Benchmarks have placed the M3 Max's GPU performance on par with Nvidia's laptop RTX 4080, a feat many thought impossible for an integrated chip. What makes this even more astonishing is its efficiency. While Nvidia's GPUs are known for their raw power, they're also infamous for consuming significant amounts of energy and requiring advanced cooling systems to maintain performance. In contrast, Apple's M3 Max achieves comparable performance with much lower power consumption, making it an attractive option for users who value portability and energy efficiency. But here's where it gets even more intriguing. Apple's M3 chips are built around a system-on-chip architecture. Unlike Nvidia's approach, which involves separate components, a CPU for processing, a GPU for graphics, and additional chips for artificial intelligence tasks, Apple's SoC design integrates everything into a single chip. This tight integration allows Apple to optimize communication between components, resulting in faster processing and lower energy consumption. Think of it like this. Instead of multiple people working on separate tasks in different rooms, Apple has everyone working together in one space, passing information instantly and seamlessly. This efficiency is why Apple's M3 chips outperform expectations in both artificial intelligence and graphics benchmarks. So what does this mean for Nvidia? The stakes are enormous. Nvidia's business model revolves around selling discrete GPUs, which are standalone components that users or manufacturers add to devices for better performance. This model has worked incredibly well, especially in gaming and artificial intelligence markets where discrete GPUs dominate. However, Apple's M3 chips challenge the very necessity of discrete GPUs for many applications. If Apple can deliver comparable performance in a more compact, efficient, and integrated package, why would developers, gamers, or businesses opt for Nvidia's bulky, power-hungry hardware? The implications of Apple's M3 chips extend beyond raw performance. By leveraging its proprietary chip designs and software ecosystem, Apple is creating a level of optimization that Nvidia simply cannot match. Every aspect of the M3's performance, whether it's rendering graphics, processing artificial intelligence tasks, or managing multiple applications simultaneously, is tailored to work seamlessly with Apple's macOS and other software. This integration provides a user experience that feels effortless, while also squeezing out every ounce of performance from the hardware. Nvidia, on the other hand, faces the challenge of making its GPUs compatible with a broad range of systems, often losing some efficiency in the process. This isn't just about technology. It's a clear strategic move by Apple's CEO, Tim Cook. Under Cook's leadership, Apple has redefined itself as a company that controls its entire hardware and software ecosystem. The decision to abandon Intel processors and develop its own silicon was a bold gamble, but one that has paid off in spades. The M1 and M2 chips proved that Apple could compete in the world of high-performance computing. With the M3 lineup, Cook isn't just competing. He's aiming to disrupt markets long dominated by Nvidia. This is about more than selling laptops. It's about positioning Apple as a leader in artificial intelligence, gaming, and enterprise computing. The M3's artificial intelligence capabilities in particular are worth noting. Apple has equipped these chips with neural engines, specialized components designed to accelerate machine learning tasks. These engines can handle processes like image recognition, natural language processing, and predictive modeling with incredible speed and efficiency. Recent artificial intelligence benchmarks revealed that the M3 Pro outperformed Nvidia's RTX 4090 in certain machine learning tasks, a result that has sent shockwaves through the industry. While Nvidia's GPUs remain the go-to hardware for large-scale artificial intelligence training, Apple's progress suggests it's only a matter of time before its chips are considered serious contenders in the artificial intelligence space. But why now? Why is Apple pushing so hard to challenge Nvidia? The answer lies in the growing importance of artificial intelligence and the cloud. These technologies are shaping the future of everything from entertainment and healthcare to transportation and finance. By making chips that excel in artificial intelligence tasks, Apple isn't just enhancing its own products, it's laying the groundwork to compete in markets where Nvidia currently reigns supreme. Imagine a future where Apple not only dominates personal computing, but also powers the artificial intelligence infrastructure behind major industries. That's the vision Tim Cook is pursuing, and the M3 chips are the first step toward making it a reality. The release of the M3 lineup has also sparked speculation about Apple's ambitions in gaming. Historically, Apple has struggled to gain traction in the gaming world, with most developers optimizing their games for Nvidia and AMD hardware. However, the M3's GPU performance changes the equation. If Apple can convince developers to optimize their games for its hardware, it could finally carve out a significant share of the gaming market. And let's not forget Apple Arcade, a subscription service that could become a major platform for M3 optimized games. So where does this leave Nvidia? The company still has plenty of advantages. Its GPUs are deeply entrenched in the artificial intelligence and gaming ecosystems, and its CUDA platform is a critical tool for researchers and developers. However, Apple's challenge is unlike anything Nvidia has faced before. This isn't just another competitor. It's a tech giant with the resources, innovation, and ecosystem to redefine how high-performance computing is done. The M3 chips are a warning shot, and Nvidia will need to respond quickly and decisively if it wants to maintain its position at the top. The question now isn't whether Apple's M3 chips will impact Nvidia, it's how much they'll disrupt the status quo. Can Nvidia adapt to a world where integrated chips are becoming the norm? Or will Apple's vision of efficient, seamless computing redefine the industry? One thing is clear. The rivalry between Apple and Nvidia is just getting started, and the stakes have never been higher. Nvidia's competitive response and strategic adjustments. Apple's M-series chips are doing to Nvidia's GPUs what the smartphone did to the flip phone, turning them into relics of the past. This is where Apple's integrated silicon, the cornerstone of its M-series chips, steps into the spotlight. By tightly weaving together a CPU, GPU, and neural engine within a single chip, Apple is rewriting the rules of high-performance computing. Nvidia, on the other hand, once the undisputed leader in AI and gaming technology, is doing anything but sitting idly by. Instead, it's doubling down on its strengths while venturing into new territories, ensuring it remains a step ahead in a rapidly shifting tech landscape. From launching groundbreaking GPUs to pioneering new industries, Nvidia's strategy reveals a company determined not just to defend its throne, but to expand its influence across every corner of computing. At the center of Nvidia's counteroffensive are its H100 and A100 GPUs, chips engineered for the most demanding artificial intelligence workloads. These aren't your average GPUs designed for gaming or casual computing. They're built specifically for data centers, where large-scale AI models and high-performance computations dominate. Think of the H100 as a supercharged engine for AI, capable of training neural networks and processing massive datasets faster than ever before. Tech giants like Meta and Microsoft have quickly adopted these chips, integrating them into their sprawling cloud infrastructures to power everything from AI chatbots to recommendation algorithms. What makes the H100 and A100 so critical is their ability to handle parallel processing on an enormous scale. In AI, tasks are often broken down into smaller parts that can be computed simultaneously, a perfect fit for Nvidia's GPU architecture. But Nvidia has taken this a step further with innovations like NVLink, a technology that allows multiple GPUs to work together seamlessly, sharing data at lightning speeds. This means that companies can now build AI clusters, essentially networks of interconnected GPUs that are orders of magnitude faster than what was possible just a few years ago. Nvidia's chips have become indispensable tools for companies pushing the boundaries of AI research, ensuring its relevance in an industry where speed and scalability are king. But Nvidia's strategy isn't just about building the fastest GPUs. It's about meeting a growing demand that shows no signs of slowing down. Recently, Nvidia called on its manufacturing partners, including SK Hynix, to accelerate the production and delivery of chip components. The urgency behind this move highlights the insatiable appetite for AI hardware. With more businesses integrating AI into their operations and tech giants expanding their AI-driven services, the demand for high-performance GPUs has skyrocketed. Nvidia knows that staying ahead means not only innovating, but also ensuring it can deliver chips faster than its competitors. The numbers paint a clear picture. Nvidia's H100 GPUs are reportedly selling for tens of thousands of dollars per unit, and yet demand still outstrips supply. This has created a unique challenge for Nvidia, not just staying ahead technologically, but managing the logistical hurdles of scaling up production. By working closely with partners like SK Hynix, Nvidia is tackling this issue head-on, ensuring that its supply chain can keep pace with the exploding AI market. However, Nvidia isn't putting all its eggs in the AI basket. The company has also been aggressively diversifying into other sectors, each with the potential to reshape entire industries. Take cloud gaming, for example. Nvidia's GeForce Now service allows gamers to stream high-quality games directly from the cloud, eliminating the need for expensive gaming hardware. All the processing happens on Nvidia's servers, which use their powerful GPUs to deliver a seamless gaming experience over the internet. This not only makes high-end gaming more accessible, but also positions Nvidia as a key player in the future of digital entertainment. Then there's the Metaverse, a virtual world concept that has captured the imagination of tech companies and investors alike. Nvidia has taken a bold step into this space with Omniverse, its platform for creating and simulating virtual environments. Unlike traditional gaming engines, Omniverse is designed for professionals in industries like architecture, engineering, and film. It allows users to collaborate on complex projects in real time, all within a simulated 3D space. For instance, an architect in New York and a designer in Tokyo could work together on a building model, tweaking details as if they were in the same room. Nvidia envisions Omniverse as the backbone of the Metaverse, providing the tools to build, simulate, and operate these virtual worlds. Autonomous vehicles are another area where Nvidia is making significant inroads. The company's Drive platform provides the computational power needed for self-driving cars, which rely on AI to process data from sensors and make split-second decisions. Nvidia's GPUs are central to this process, enabling vehicles to analyze their surroundings, predict traffic patterns, and navigate safely, all in real time. Major automakers like Mercedes-Benz, Volvo, and Toyota have partnered with Nvidia to integrate its Drive platform into their autonomous vehicle programs, further solidifying Nvidia's role in shaping the future of transportation. What ties all these efforts together is Nvidia's ability to innovate across multiple domains, leveraging its expertise in GPUs to tackle challenges beyond gaming and AI. This diversification not only insulates Nvidia from market fluctuations, but also positions it as a leader in emerging industries. Whether it's powering the next wave of AI breakthroughs, redefining entertainment through cloud gaming, or enabling the autonomous vehicles of tomorrow, Nvidia is making strategic moves to ensure it remains indispensable. As Nvidia pushes forward with its H100 GPUs, Omniverse, and autonomous vehicle platforms, the battle is far from over. Can it innovate fast enough to stay ahead? Or will Apple's disruptive approach force a reevaluation of Nvidia's strategy? Only time will tell. Apple's AI ambitions and their potential threat to Nvidia. Apple's M3 Pro isn't just a chip. It's a silent competitor capable of challenging Nvidia's decades-long reign over AI hardware. Apple's foray into AI, led by its neural engine technology and the growing capabilities of its M-series chips, is not only raising eyebrows, but also positioning the company as more than just a manufacturer of iPhones and sleek laptops. Now it's a serious contender in a cutting-edge space long dominated by Nvidia. And the implications for this rivalry are massive. Apple's AI ambitions aren't a recent development. They've been quietly building for years. With every iteration of its M-series chips, Apple has demonstrated an increasing focus on AI performance, integrating specialized neural engines directly into its SoC designs. These neural engines are purpose-built to accelerate machine learning tasks, such as image recognition, natural language processing, and on-device AI applications. Unlike traditional GPUs, which handle a variety of computational tasks, Apple's neural engines focus solely on AI, making them exceptionally efficient for specific types of workloads. The latest M3 Pro chip underscores Apple's growing presence in AI. In recent benchmarks, the M3 Pro shocked analysts by rivaling Nvidia's high-end GPUs in certain machine learning tasks. For instance, image recognition models and natural language processing pipelines ran just as smoothly on the M3 Pro as they did on Nvidia's RTX 4090, a GPU that costs far more and consumes significantly more power. This wasn't supposed to happen. Nvidia's GPUs have long been considered the backbone of AI computing, powering everything from ChatGPT to medical research platforms. The fact that Apple's integrated chips are delivering comparable results in select AI benchmarks is a clear signal. Apple is no longer playing catch-up. It's shaping the conversation. But Apple's ambitions go beyond just making powerful chips. There are growing rumors that the company is developing its own large language models, similar to ChatGPT or Google's Bard. If true, this would be a significant escalation in Apple's AI strategy. Apple has historically positioned itself as a privacy-focused company, avoiding cloud-based data collection where possible. Developing in-house AI models would allow Apple to maintain its privacy-first philosophy while creating new, innovative products that integrate deeply into its ecosystem. Imagine a Siri that doesn't just answer questions but understands context and nuance, or AI-powered workflows that anticipate your needs across all your Apple devices. These possibilities are no longer hypothetical. They're becoming increasingly plausible. What makes Apple's approach so unique is its ability to leverage its ecosystem in a way that Nvidia simply cannot. Nvidia is undoubtedly the leader in large-scale AI applications, providing GPUs for training enormous models in data centers around the world. But Apple's strength lies in its ability to integrate AI into consumer products seamlessly. The neural engines in Apple's M-series chips enable real-time AI processing directly on devices, eliminating the need for constant cloud connectivity. This has huge implications for privacy, speed, and energy efficiency, three factors that are becoming increasingly important to both consumers and businesses. Consider this. Apple already has over 2 billion active devices in its ecosystem. If Apple were to roll out AI features powered by its own neural engines and large language models, it could instantly impact millions, if not billions, of users. And this doesn't just stop at iPhones and MacBooks. Apple's foray into augmented reality with devices like the Vision Pro provides another opportunity to integrate cutting-edge AI capabilities. Whether it's personalized assistance, real-time object recognition, or contextual suggestions, Apple's control over both hardware and software positions it uniquely to deploy AI in ways that feel intuitive and impactful. So, where does this leave Nvidia? Nvidia's GPUs remain the gold standard for large-scale AI training, powering the massive data centers that companies like OpenAI and Google rely on. However, the shift towards on-device AI, which Apple is championing, represents a new frontier. As AI models become more efficient and compact, there's a growing trend to move AI processing closer to the end user. This is especially true for applications where privacy, latency, or connectivity is a concern. Apple's chips are tailor-made for this environment, giving the company a significant edge in emerging AI markets. The stakes are even higher when you consider how Apple could expand its AI efforts into enterprise and cloud computing. While Nvidia dominates in data center hardware, Apple could leverage its expertise in chip design and integration to create competitive solutions for smaller-scale AI applications in business environments. For instance, Apple could develop compact, energy-efficient AI accelerators designed for edge computing, small servers or devices that process data locally rather than in the cloud. Such a move would directly challenge Nvidia's dominance in enterprise AI hardware, opening up a new battleground in this rivalry. There's also the question of how Apple's AI advancements might influence software development. Historically, Nvidia's CUDA platform has been a major driver of its success, creating a loyal developer community around its GPUs. But Apple's control over its ecosystem means it can optimize software specifically for its hardware in a way that no other company can. This includes its AI development frameworks like Core ML, which already allows developers to create machine learning models optimized for Apple's chips. As Apple continues to push the boundaries of AI hardware, its software tools could attract more developers, further strengthening its position. What's particularly intriguing about Apple's strategy is how it aligns with broader shifts in the AI industry. While Nvidia's focus on large-scale, cloud-based AI remains critical, there's a growing demand for solutions that prioritize efficiency, portability, and privacy. Apple's M-series chips, with their integrated neural engines, offer a glimpse of what this future might look like. Whether it's real-time language translation, augmented reality overlays, or intelligent task automation, Apple is positioning itself to lead in a world where AI is deeply embedded into everyday experiences. The race for AI innovation and geopolitical obstacles. Nvidia isn't just fighting Apple, it's battling global turmoil. US-China trade restrictions have slammed the brakes on Nvidia's ability to sell its most advanced GPUs to one of its biggest markets. These restrictions are part of a broader effort to prevent sensitive technology from being used for military applications. But they've also created significant hurdles for Nvidia, which counts Chinese companies among its major customers. Now forced to create weaker versions for China, Nvidia is losing revenue and facing production chaos at a critical moment. These geopolitical challenges are compounded by the global semiconductor shortage, which has strained supply chains across the industry. Nvidia, like many of its competitors, relies on Taiwan Semiconductor Manufacturing Company for chip production. TSMC is the world's largest contract chipmaker, and its advanced manufacturing capabilities are essential for producing the complex designs Nvidia requires. However, TSMC's capacity is finite, and with demand for semiconductors skyrocketing, securing enough production slots has become a critical challenge for Nvidia. To address these issues, Nvidia has been working to diversify its supply chain. The company has called on partners like SK Hynix to accelerate the delivery of next-generation components, ensuring it can meet the growing demand for its GPUs. This is part of a broader effort to make Nvidia's supply chain more resilient, reducing its dependence on any single supplier. However, building a more diversified supply chain is easier said than done. It requires significant investment, long-term planning, and the ability to navigate a complex web of international trade regulations. Apple, for its part, is not immune to supply chain challenges, but it has certain advantages. Like Nvidia, Apple relies heavily on TSMC for its chip production, and its chips are also manufactured using cutting-edge 3-nanometer processes. However, Apple's strong relationships with suppliers and its massive purchasing power give it a level of influence that few companies can match. When global bottlenecks occur, Apple's ability to secure priority access to production capacity often puts it ahead of the competition. This has allowed Apple to maintain a steady supply of M-series chips, even as the semiconductor industry faces unprecedented demand. Despite these strengths, Apple's reliance on TSMC also poses risks, particularly given the geopolitical tensions surrounding Taiwan. As the US and China continue to compete for dominance in the tech industry, Taiwan's role as a semiconductor hub has made it a focal point of international politics. Apple and Nvidia aren't just rivals. They're navigating a world shaped by fierce competition, political tensions, and an industry on the edge of transformation. The real question isn't just who wins, it's whether either can survive the pressure. One thing is clear, the race for AI dominance is a fight to the finish. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.